So we can combine the marginal cost of capital and investment opportunity schedules from a specific firm. We're going to do this for Unilate, so we can find the specific cost of capital for that we would use for determining projects' net present values. The investment opportunity schedule is a graph of a firm's opportunities ranked in order of projects and internal rates of return. From before we came up with this is the Unilate's marginal cost of capital schedule. So up to 61 million, we are our, if I could get the right, come on, there we go. So up to 61 million, our weighted average cost of capital is 10%. From 61 to 120, it was 10.5%. And then from above 120, it was 11%. So we look at Unilate, we have the following investment opportunity schedule. So there are 5 projects, A, B, C, D, and E. They have different amounts, and 39 million, anywhere from 25 to 39 million. They generate various cash flows, different lives, and so forth. But they have the following internal rates of return: 10.2%, 11.5%, so 12.1%, 11.7, and 10.7. So what we would do is we would rank those in order from highest to lowest, and we'll see that on the next schedule. So the first project we would pick would be project C, and then project D, then project B, and then E, then A. So each of these is going to add an increment to the cost of to the capital structure of Unilate's debt or capital. Sorry. So our first project was 39 million, I believe. I'm going to have to go back and forth to keep track of these. 12.1%. So that falls within the 60 million. So let's go back. So then 39 and 25 is 64. So the IRR on that, is that right? So hold on. So actually 39 and this, so whoops, I screwed that up. So start over here. So the first one we're going to accept is C. So that's 36 million. So it's going to fall right here. So it falls within the 64 million. So then go back. Whoops, wrong direction. So then D is 29 million. So the two of the so 36 and 29 is 65, so that's over the 61 million. So our weighted average cost of capital will have increased up. So 65 is somewhere in that neighborhood. So then the next one is the 11.5% project. So let me go there. The 11.5% is 25 million. So we can accomplish that within the within the 120 million, and we can also accomplish the 10.7%, and that's the E of the 25 million. So that's 115 million. So it's inside the 120 million. The final project, project A, takes us over the limit for the 120, and it also is below the weighted average cost of capital at both levels. So we would definitely reject that. But in this case, our optimal capital budget would be 115 million because these projects C, D, B, and E would all improve the value of the firm because those the returns on those are greater than the weighted average cost of capital. So just a summary here: weighted average cost of capital versus investors' required rates of return. Return to investors are for debt. R subscript D is equal to the yield to maturity on the bonds. Investors' required rate of return. Cost of the firm is R sub D, or the yield to maturity. That's the before tax cost of debt. The actual cost of the firm is the after-tax cost of debt. So we take our subscript DT is equal to the before-tax cost of debt multiplied by 1 minus the marginal tax rate. With regard to equity, we look at the cost to or return to investors, or investors' required rate of return. This is our constant growth model. It's our current dividend multiplied by 1 plus the expected growth rate divided by the current price plus the growth rate of the stock. This can also be D1. And in all cases, the cost of the firm is the same calculation, but this is the cost of retained earnings. If we require external financing, we have to include the flotation costs. And just one final note down here: if G equals note the investor required return for R sub S, or the cost of retained earnings, is equal to the cost of preferred stock, and if the cost of R sub E is the cost of issuing preferred stock, which is our PS. So those would be indifferent in the case where the growth rate is 0. Not many firms doing well that have a 0% growth rate.